will be held by Luca Cipriani and Matteo Suppo, both from Arduino, and they will talk about scalability in Go. So now it's up to you, Luca.
Hi, everyone. So I'm Luca Cipriani. Actually, I run my own company, but it's hidden. So you cannot find anything about that online. But I mainly am the CIO of Arduino. And Matteo is my colleague, basically leading the back end of this project that I'm going to show you. I'm also product manager of this project. This project is an incredibly new one. And we faced a lot of issues in scaling applications. So we decided to be very opinionated on how the application should be built, because it is an application really involving a lot of different contents, mainly web application, so everything on the web. But as you know, if every of you knows about Arduino, which is basically an electronic board, we also face the issue to have a desktop application communicating directly with the device. So there is a mix in this project of different problems. So the project, as said, is named Arduino Create, and it is more like an ecosystem of different applications. So we are working on an IoT platform that is very, very complex, so we'll be focused later, probably this year. While we try to, oh, pardon, I'm just updating the wrong slides. We try to create a single platform for makers, so where they have all the tools in the same place. So we immediately started facing the hardest problem, so having a web IDE. Given the experience with other web IDEs, I don't know how many of you know Cloud9, but I was working with them for a while. So this is actually my second web IDE, but it's a completely different experience because it's much focused on not real hardcore developers, but more like beginners. So we decided to basically switch and initially to have a mix between desktop and web applications. And most of the components are open source, so we are trying to open more and more our code base, even if the web IDE is a software as a service module. This is how the web IDE looks like in dark mode, because we love dark mode. But so as you can see, it's very simple. There is no concept about file directories. It's more user-oriented, so there is a lot of UX involved right here. So big icons like to compile on the top to upload directly on the board. There is an auto-detection of your board as soon as you plug them. And all of this is basically just client-side code running on AngularJS, and everything in the backend is written in Golang. We also decided to try to get rid, and we did actually after a quite hard implementation, to get rid of WebSocket to have really everything very, very scalable and incredibly fast. So how all of this work to immediately try to solve a lot of real problems that we are facing. You know, Arduino is having more or less 10 million users per month on our website, and this project is already running at about 1 million users per month, so it's like an incredibly massive website. The nice thing is that we are only using right now, like in total 4 medium servers on AWS, running all that load, and even compiling server side. So it is incredibly optimized, thank you, Go. It's also everything designed for failure. So we have 2 servers for each component, and all the components are completely independent. So we don't care if one of the compiler servers is failing, because it is part of a completely different cluster about having builders servers, and they can scale and fail independently, while we have other servers for the REST API about the user information, and so forth. So about performance, as I said, we still have a lot to do, but we already run some tests I don't know how many of you used AWS Lambda in the past, but we were actually cooperating with them quite a bit, and we found that for our personal use case, using AWS Lambda was not the best thing to do for both performance and cost. And we also had to deal a lot with security, especially in the client-side application, because the website is HTTPS only, and at some point in time we had a client-side server, so running on the desktop of the user, but it has to be reached directly from the web interface. So that means everything needs to run HTTPS, or otherwise your browser blocks it. So we started generating certificate directly on the client of the users, adding certification authority inside the PC, and so forth. And this has to run on all operating systems, all the major operating systems, so basically Mac, Linux, and Windows. And we also had everything on ARM processor as well. So it's quite hard. But the most difficult thing was to try to involve the community more and more, because they were so attached to our whole, let's say, Java IDE, which has already a lot of features. So we try to cut all the very tiny features and just have the essential one and go online as soon as possible. So those are the components we are using. Basically Goa, and my colleague Matteo will explain a bit about that a bit more in depth. This really gave us the possibility to have a pure design-based API. So we first write the design of the API, and just as the last small thing, we implement everything. So we already have the documentation for free, and you will see more details later. Then we use Drone for continuous integration, because it's incredibly simple to use, and it allows us to have everything inside the same repo. We made a deal with Amazon AWS, so they are basically offering us the servers for free users. And we started using Compose.io, because initially we were using a lot RethinkDB. Then RethinkDB community just decided to basically bring down the enterprise support, let's say. So we are eventually moving to PostgreSQL. Then there is the builder. The builder is an open source component. Basically, it is the component written in Golang and used by both the Java IDE and the web IDE. So the difficult thing was even to try, at least for me, to manage two different things. One really firmware based on hardware all the time, the other one doing web development all the time. And we started bringing together our efforts and say, oh, let's try to have just one tool that is going to be used by the Java application and by the web application. So we ended up creating the Arduino Builder, which is a Golang tool. Relatively well written. Obviously, it started as a Java port, so then we tried to add new features and a REST API on top of it. And the Arduino agent. The Arduino agent was a fork of another project, so we are trying to rebuild them again, but it's already used in production by millions of users. So something more about Goa, and Matteo will take over.
Okay, so the concept of Goa is that you write the design of the APIs, and then you generate the code for implement the API. What does it work is that you write the design in a specific language, which is Go, but it is declarative. Then you generate the components, and they will create the main.go, if it doesn't exist. An app directory which contains everything from the HTTP server, JSON encoding, or XML encoding, if that's your thing. And one file for every resource specified, as we will see. The cool thing is that once you generate the main.go and the resource-specific file, those are only stubs. Then you can change them every way you want. But the app directory, which is what's doing the real work, will be auto-generated, so you should never touch it. This is the design file. As you can see, it's very simple to understand. We declare the name of the API, the title, the description, and this is just documentation. It will go in the documentation file. We tell it that we want to consume application JSON, and so it will generate the helpers to decode and encode JSON. We specify that we want it to only allow requests from star.arduino.cc domains. And it will generate a method that will only accept requests or generate an error.
Oops.
What? Okay, this is our resource looks like. A resource is meant in the sense of the REST resource. Is a part that will allow different actions. Here, for example, we have a resource named boards that are the hardware boards that we sell. The base part is the part of the that every action will have. And the action, for example, list, this is it's very simple to understand. The description will go in the documentation. The routing will be a get request to the base path, and it can return as a response a collection of boards. A board is defined as go ahead.
It's like stuck completely.
Yeah.
Woohoo! Nice thing. Don't know
Come
what's
on,
going
there's
on.
not much more I can tell about this slide,
Okay,
except that you used a non-monospace font, and I hate you for that.
cool. Okay, I'm gonna reboot everything.
Okay. So basically, we define a response method. It's blue.
This is the response method.
That will describe which fields are contained in that method, in that resource, and this will translate to an abstract in Go that will contain these fields. For example, if I define a board, it will have a name and a version, and so the struct generated will be a struct with name and version with already the JSON tags to make it lowercase, because that's prettier. So when we generate, what happens? That we get a file that contains a controller function that accepts this struct, and a context which contains the request and response that you could need. And the cool thing is that you don't have to worry about encoding, because that's already taken care of by the Go generated code. And it's coming, no?
No.
Okay.
Let's go ahead.
Okay. And what happens is that this
PDF.
Goa generates also
Support
the
PDF.
documentation in the form of Swagger, for example.
It's
But it can also generate some client code. For example, it can generate the JavaScript code to query the APIs. We aren't using that because we are using another thing that grabs the things from the Swagger JSON file, but that's another story. For example, it can create also some test helpers. So you can test your controllers without worrying about spawning a server, and and so you can have a unit test in a much more simpler way by abstracting everything that is not used. What really matters to us is that we can also serve the Swagger documentation along with the APIs. So because the people who are writing the APIs are not the same that are using the APIs, they can check the documentation online and see if the understand how it's working.
This is mainly because the front-end theme is a completely different theme than the back-end theme. So what happens is that they should be free to immediately just read the documentation and then out of the documentation implement the AngularJS method to do everything. Okay, looks like it is working again. Just give me a few seconds maybe. Okay, it's restoring everything. And it should be there in a second.
So any question about that little part? We wanted to actually show you, but we couldn't.
We're going to do that. And in the meantime, let me explain a bit more about the internals of the application itself. So what is going to happen when you plug in basically a board is that the agent, our Arduino Create agent, so the open source application, automatically is able to discover everything that you attach actually, and eventually expose that to our client-side application. Then after you plug in a board that we actually know, so it's in our database, we are able again to show you everything about your board. Like you can compile it because we know exactly what type of board it is. Obviously, we are able to have even edge cases and auto-detect them. So you can, in the case your board is actually not in our database, but is compatible with some other boards, you can actually select it manually. So finally,
Computer sucks.
Yeah, it really sucks. But now recovered. And
do you want my computer?
No, it's fine. I think we finally did it. Maybe, yes. Okay, it took ages. But yeah, hey, here we are. Sorry for that. So let's keep a bit and just take a look at the documentation. So the documentation, I said, is auto-generated completely when you write the code. And actually there is even, I don't know how many of you are using Swagger or know about that. Okay, Swagger is incredible because you are able to define your basically YAML file and have everything. But what Goa does is auto-generating the YAML file for you. So that's incredible because you basically have a full interface where you can test everything running on your own server or eventually let your customer test your API, because this project is not only about having final customers, let's say like B2C, but it's also B2B. So we have partners like Intel and Microsoft that are actually using our product as an API. So that's very interesting for them to actually test the API and give us suggestions. So just few things because I think we run out of time due to the problems, but let me speak a bit about the deploy, and we deploy everything. So we are actually using Drone.io. Drone.io is not anymore let's say running company trying to get money out of automatic deployment, but they decided to switch completely to a fully open source project with no profit. But the project is awesome because it's just a simple Go application that allows you to define actually very small YAML file to deploy something. So basically, I'm gonna click here. This is how a drone file looks like. I don't know if you can read it fully, but basically you can define something to build your application. Then you define your dependencies, eventually with another Docker image. Then some commands you are gonna launch. And finally, this is very important for us. So whenever there is a tag event, we are actually deploying and running this. What does that mean? That we are able to deploy it with just a single click in GitHub. We just create a new tag. We then create a release in GitHub. Drones create everything. And then what happens is just that we upload some file on AWS. And finally, we store that on S3. We run our provisioning system that is based on SourceStack. And everything is online. So no need of any other changes. This is how drone works. So take a look at that. And finally, the real thing, and this is mainly my business, was to trying to optimize everything and put everything together. How that works. So we have right now, finally, after removing WebSocket, because we were using Node.js, that's for historical reasons maybe, because the first implementation of this application was running on an actual physical board, running on ARM. Then what happened was that we basically migrated to a completely static application, as said, with AngularJS. So we are now able to only have Nginx servers, pure Nginx server serving static files. We are also trying to add a CDN. We had some issues with the caching and redirect, but we are trying to solve them. Then to actually deploy the REST API, I know everyone probably here is a big fan of Docker, but I don't think it fits all the needs. And it was not our use case because we had a lot of different endpoints. So we prefer to have just a simple EC2 instance, just a GoLab binary. So honestly, I see big advantages in using Docker with different stacks like Node.js and everything else. But for Go, you just need a binary and a configuration file. So who cares if you have to run a Docker or not? It could be very handy in development mode, but when you run and you really need to scale, you need bare metal. Not really bare metal, let's see, because we are again on top of EC2, but you can really tune everything. And our Nginx configuration is not that trivial. Again, because we also have a lot of legacy application we have to deal with. Then we implemented auto-elastic groups. I don't know how many of you went to the other meeting with the guys at Datadog, but we really love Datadog. And what we did was to create a script. Datadog is a system to monitor your servers, application, whatever, even Docker containers. And you can decide on top of your specific metrics, so not just the CPU load. For us, it could be that after, I don't know, 500 users on the same process, then we spawn a new process, or after a few thousand users on the same server, we spawn a new server. That's what we do. Then everything is provisioning with SourceStack. SourceStack is written in Python until there will be another 1,000 configuration management system.
Actually, in the latest talk, they were talking about they are migrating to Go.
Yeah, that's indeed a nice news. I mean, I am from a Python development stack. The same was for Matteo. And so looks like really Go is bringing, again, the community moving faster. And there are already a lot of good Python environment, but having them again in Go, I think the huge advantage as I can see as a DevOps mainly, is that you can really simply push that with a binary. This is massively, and that's basically the reason why Google is using it. Everything else is just nice to have. But the main thing is that you have a binary and you can pass that binary with rsync and you're online. No hassle, no dependency management, no NPM nightmare, no pip nightmares, no new version of dependency or the system level. You just have a binary, run it, and it works. Then we have just few domains like api.arduino.cc/something. So we created a endpoint every REST API. So we really have microservices in productions. We have, I don't know how many, but probably 12, 15 subroutes, probably with Stripe, with create users API, and whatever. We are building more.
But only 3 of them are using the new Goa.
Exactly. So the other nice thing is that we are able to respect the same API. Then we can change the underlying technology. So we started with Hago, then we migrated again. No, we started with Gin, then we migrated to Hago, and then we started using Goa, and so forth. We can change everything all the time. And eventually, we are even trying to move to Beanstalk for obviously reason, like having me sleeping nice during weekends. So thank you again, and sorry for the interruption. But I very appreciate your patience. You can contact us if you have any other questions. So if you can ask us right now everything about our application, please do right now. Thanks.
If someone wants to ask something to them.
Hi. Just a question about around the actual tool. So I was wondering if the tool is if you open the API. So and if so, if you think that that is also a model for having like massively distributed code for like updates over the wire for Arduino.
Yeah, that's actually something that we skipped due to the technical issues, but. So let me explain. The builder, so the component that you install on your own server, on your whole PC, as said, it is open source. And the nice thing is that it automatically updates. So there is an update over there of that one. Then there is another upload model for the board themselves. So we will be able, and we are actually already experimenting a lot about that, about updating your board from the cloud directly. And the third thing about the Open API, yes, we were also even eventually trying to provide a like super lightweight, complete set of tools to run this web IDE on your own machine, in the same as Luck does with their application. So. Yeah, we are trying to move our efforts, I say, with the Java IDE and the web IDE to have just one application all together using the same API set, basically. So it can be actually written in every language you like, but we incredibly love Go, as said, and in that case, even deploying and distribute the application is incredibly easy because you just have to give the customer an installer that ships Go something with a nice AngularJS interface, then you can use whatever you like. So yeah. Anything else? Yeah.
Hi. There has been a lot of conversation in the Golang community about the performances of the standard HTTP library. Are you using the standard library or fast HTTP?
No, we are using the standard one because this is mainly due to some issues with HTTP2 and AWS. I'm not gonna dig this much more, but basically how the load balancer in AWS works is not really allowing you to be so nice with HTTP2. And the other thing is also that some browsers don't deal very well with certificate recognition and HTTP2. So, you know, some old browsers, let's say, are not that friendly. So we prefer to stick to that. But yeah, we experimented a bit. It's in progress. Not right now, obviously, it's not like our main priority. Yeah, there is a lot of improvement opportunity, and that's why we are trying to open more and more to the community, because they really helped us solving a lot of security issues, especially. So I said, we didn't figure out that we had a lot of issues in the desktop application initially, because, you know, it's like running a web server on the client machine that is updating over the air. So we had to straighten that and have a signing key for every request. Otherwise, a potential attacker will be able to run a random code on your machine. That will set, so we now have key authentication, and the whole payload is encrypted and verified with the key. So we are sure that the request has to be from create.arduino.cc, and the real one having the private key. So, you know, you discover those things during beta development. That's why we didn't publish that everything for basically 2 years. So we were working in this project already in 2015. Maybe even before, in 2014, we started on the physical board. So yeah, thank you so much. Anyone else? Question or just a coffee for everyone? I'm still available, or you can just write me an email, whatever. Thank you very much.